Okay, so in this video we're going to talk about this concept called multiplicity. So if you'll notice here we have our instructional piece which discusses what multiplicity is, and then right here we have our graph, and this is from our previous example. So the polynomial for this graph is x cubed plus 3x squared minus 4. Okay, so a couple things that we need to look at. Let's look at the definition first, that x minus r is a factor that occurs m times in the factorization of a polynomial expression p. Then r is a root with multiplicity m. So m represents the times that we see the factor. So in this example, when we factored, we got x plus 2, x plus 2, x minus 1. Okay? And this is in the previous video. And so using this example, we want to identify the multiplicity of the factors. So because we have two factors, the multiplicity here is equal to 2. The multiplicity here is equal to 1. It's just how many times the actual factor occurs. Now, certain behaviors exist when we have different types of multiplicity. So notice that we have 2 here, and so this guy, this is the 0. So what's a little deceiving here is the actual 0 is equal to negative 2. The multiplicity is 2. And so notice that the graph, what happens is as we're going up the actual graph and increasing, we hit the 0 and then we bounce off. Okay? And so this is where our multiplicity is equal to 2. And our 0 is equal to negative 2. Now, as we decrease and come back up, this is where our multiplicity is equal to 1. The 0 is also equal to 1. That's just coincidence. So if the 0 is equal to 2, the multiplicity would still equal 1 or whatever. So just that the numbers turned out that they're same with multiplicity. So it goes through the actual 0. And so we have a pattern here. And so we'll discuss the pattern in a second, but the basic idea is multiplicity is how many times we see the 0. And so because we see this guy twice, the multiplicity is 2. Because we see this guy once, the multiplicity is 1. Pattern with this. When our multiplicity is even, okay, so even multiplicity, the graph will bounce off the 0, okay, when it's even. The graph will go through the 0 when it's odd, okay? So just to give you an example, if I had x plus 4, x plus 4, x plus 4, okay? And then I had x minus 1, x minus 1. So m is equal to 3 here, m is equal to 2, so this guy will go through, and this guy will bounce. Okay? And so here's a really generic picture, and I'm only doing it based on the behaviors that I'm not graphing it on my calculator. I'm looking, I know I have a 0 at negative 4. I know I have a 0 at 1. And I know because I have 5 factors is 5th degree, so it's going to alternate. But what's going to happen is it's going to be kind of an S shape. It might be a little bit more goofy than that. But I'm going to come down. It looks S-shape because of the fact that I have 5 factors, and a lot of them are the same. And if we were to graph it, it would look a little different. But I know it's going to go through at negative 4 because the multiplicity is odd. Okay? And I know it's going to bounce because the multiplicity is even. And so this is not close to a specific picture. The only thing that I know definitively without using a calculator right now is that at this 0 it's going to go through, at this 0 it's going to bounce. And the other things that I know are the end behavior, because it's an odd function, right? It would be something like x. It would be something like x to the fifth. So I know it's going to have an end behavior like this. Okay? And so that's what I can get from the graph regarding multiplicity. It's not a perfect picture, but I have some sort of behavior at the zeros and knowing the end behavior on the outsides because of it being an odd function with a positive leading coefficient.